Hey, Algebra 1, welcome to UF3, Modeling with Functions. We're going to start right here with this, bolded words. We've got identifying independent and dependent variables. The input, wow, we've been using that one, input, X. Now we've got independent variable, domain. All those things mean basically the same thing, right? Our inputs here. So our input is the independent variable. The output is the dependent variable. This is a really important statement that I don't think gets enough credit here. The dependent depends on the independent. Okay, let me say that again. The dependent depends on the independent. Wow. Okay, Mr. Brayman, that's fantastic. What are you trying to get at? Well, let's see. Let's see here. Identify the dependent independent variables in each situation. In winter, more electricity is used when the outside temperature goes down and less is used when the outside temperature rises. So what depends on what in this case? In other words, the electricity use depends on the temperature. The electricity use depends on the temperature. The dependent variable depends on the independent variable. So in this case, the dependent variable is the electricity use. And the dependent variable is the temperature. This is one, I want to say easy, but this is one straightforward way. If you can make the statement of the blank depends on the blank, the dependent depends on the independent, you know which variable is which. Let's look at another example. The cost of shipping a package is based on its weight. The cost depends on the weight. The cost depends on the weight. The dependent depends on the independent. The cost is the dependent. It depends on the weight of the package. Okay, okay. The faster Tom walks, the quicker he gets home. Think about this for a second. The faster Tom walks, the quicker he gets home. What'd you come up with? Did you come up with the time to home depends on Tom's speed walking. Depends on the speed that Tom walks. In other words, the dependent, the time depends on the speed. The time depends on the speed. Okay, this is kind of like your one level stuff in here. What is the independent? What is the dependent? Can you take a situation and rewrite it in the statement of the blank depends on the blank? There we go. Okay. All right. Yep. Double checking. Next page. Applying function notation. Here we go. We're getting to this business now. Function notation. This is your f of x. Y is a function of x. Y equals f of x. Okay. If x is the independent variable, like we've just talked about, and y is the dependent variable, we can use function notation. So we've got this function notation, which you can use to write y equals f of x. F names the function. It could be G, it can be X, it wouldn't be X. G, Q, R, M. When an equation in two variables describes a function, you can always use function notation to write it. The dependent is a function of the independent. Y is a function of X. Y equals f of X. So let's go ahead. I know that's kind of a little bit convoluted. Let's kind of look here. Write the equation in function notation. Amanda babysits and charges $5 per hour. The money earned, the amount earned try that again. The amount earned is $5 times the hours worked. The amount earned is $5 times the number of hours worked. We can write our algebraic function rule, okay? The amount earned, y, is 5 times the number of hours worked, x. I pulled that from here and here. Because the dependent variable is a function of the independent variable, we can write this in function notation. So instead of y, we're going to say the f of x is 5 times x, or f of x equals 5x. This, it's another way in this case to write y because it is a function. Okay. Those are our first 2 points. Okay. Let's see what else we can do with this. Let's see what else we can do with this. Let's model using function notation. So let's look at an example. It says, for each example, identify the independent and dependent variables. Write an equation in function notation for each situation, and then use the equation to solve the problem. So we got some stuff going on here. For each example, identify the independent and dependent variables. That's one thing we have to do. Write an equation in function notation for each situation. That's a second thing we have to do. And then the third thing is to solve the problem. So with these questions, I don't just want an answer. I want the process of how you get to that answer, that solution in context, all right? A lawyer's fee is $180 per hour for his services. How much does he charge for 5 hours? Then identify the independent and dependent. Write the statement. The dependent depends on the independent. The blank depends on the blank. The fee for the lawyer, dependent, depends on how many hours he works. Independent. The fee depends on the hours. Okay, we're going to call this H. H is hours. Again, mathematicians, we're very, very creative. H for hours. In other words, the function f of h, so the value of the function with h hours is f of h equals 180 times h. Again, this was step 1. This was step 2 because we have this function in terms of h. And step 3 is solving. The lawyer charges $900 for 5 hours of work. Step 1, step 2, step 3. Let's look at another example. The admission fee at a carnival is $9. Each ride costs $1.75. How much does it cost to go to the carnival and then to go on 12 rides? The cost depends on the number of rides you ride, plus $9 for that entry fee. The number of rides, it's not hashtag rides, it's number of rides. The number of rides plus $9. The cost, the dependent, depends on the independent, which is the number of rides ridden. We're going to, again, get real creative. We're going to call R and let that represent rides. The total function then, so again, this is our step 1. Our function f of r, our value of our function with r rides is, we do $1.75 per ride plus a $9 entry fee. Okay, that's our step 2. Our step 3 is to substitute 12 in for r, the value of the function when r is 12, because that's 12 rides. Notice how it's f of 12, the value of the function for 12 rides. F of 12 equals 1.75 times 12 plus 9. Okay, so we need to simplify. It's still the f of 12 the F of 12, and 1.75 times 9. So what is 1.75 times 12? That would be 21. So we've got 21. This is 21 plus 9. That simplifies to 30. So what does that mean? It costs $30 to go to the carnival and ride on 12 rides. That's our step 3. Solving it and then putting it into context. Okay, what I want you guys to try right now is your turn. For each, once again, identify the independent and dependent. If you can, write it out as a statement. The dependent depends on the independent. The blank depends on the blank. Write an equation and function notation, step 2. Step 3 is to use the equation to solve the problem. Kate earns $7.50 per hour. How much money will she earn after working 8 hours? Pause and see what you can do. Okay, now that we are back. Kate earns $7.50 per hour. How much money will she earn after working 8 hours? Well, let's write our statement. I'm going to write it up top because we're running out of room. The blank, and this is going to be my dependent variable, depends on the blank. So when I'm reading this, I'm saying that the money she earns, the money earned, depends on the number of hours she works. Depends on the hours worked. So the dependent, which in this case is the money earned, depends on the independent, which is the number of hours worked. There we go. There we go. Okay. Now we need to write, that was step 1. Function notation, step 2. I'm going to call X, actually we'll do H, why not? We'll get real creative. H is going to be hours worked. So the value of the function for H hours is $7.50 times the number of hours worked. There we go. We need to use this for step 3. Step 3 says, how much will she earn after working 8 hours? The value of the function for 8 hours is 7.5 times 8. The value of the function for 8 hours, the F of 8, is 60. Yay! 60 what? In other words, Kate earns $60 for working 8 hours. Okay. 1, 2, and 3. We'll have lots of practice on that. Okay. One more thing we need to think about. We've been talking about domain and range. So now we need to think about choosing a reasonable domain and range. We've talked about this too, but now we're going to formalize it. Okay. So let's do the same thing. We're going to write a function and function notation for the situation and then find a reasonable domain and range. Manuel has already sold $20 worth of tickets to the school play. He has 4 tickets left to sell at $2.50 per ticket. Write a function for the total amount collected from ticket sales. We're going to call T the number of tickets to sell. He has the F of T is $2.50 per ticket, so $2.50 times T, plus the money he's already made, which is 20 bucks. In other words, he's got the F of T equals 2.50 or just 2.5 T plus 20. And let's think about the domain. That's our independent, our T. He's only got 4 tickets left. Can he sell negative tickets? No. Can he sell 5 tickets? No, he doesn't have 5 tickets. Can he sell half a ticket? That's not how tickets work. So he could sell 0, 1, 2, 3, or 4 tickets. Now we need to know How much money has he made when he sells 0, 1, 2, 3, or 4 tickets? Well, if he sells 0 tickets, he's already made the 20 bucks. If he sells 1 ticket, now he's at $22.50. At 2 tickets, he's made 25. At 3 tickets, it's $27.50. And at 4 tickets, he has made $30. Reasonable domain with a reasonable range. I like that example. Let's take a look at another one. A telephone company charges 25 cents per minute for the first 5 minutes of a call, plus 45 cents in a connection fee per call. Write a function for the total cost of making, and total cost in dollars of making a call. M is minutes used. Again, so creative, so creative. M is minutes used. The total cost for the call is 25 cents per minute, 0.25 times M, plus this 45-cent fee. Okay? So it's only going to be, the charges only occur if the call is made. We're talking about this first 5 minutes, right? So he could have, I mean, you don't not make a call, right? So this is kind of interesting, right? I would say we've got 1 minute, 2, 3, 4, and 5 minutes, right? You don't make a 0-minute phone call. You're not going to get charged for making a 0-minute phone call, because if you make a 0-minute phone call, that means you didn't make a call. It's okay if you didn't see that right away. Okay, that's what I'm going with here. All right, substitute the values to find out. For 1 minute, that'd be like the f of 1 equals 0.25 times 1 plus 45 hundredths. This would give me 70 cents. So with 1 minute, the value is 70 cents. I'm going to keep adding 25 cents each time. With 2 minutes, it's 95 cents. With 3 minutes, $1.20. And with 4 minutes, it's $1.45. And with 5 minutes, it's $1.70. Oops, forgot my symbols here. That's how you find the reasonable domains and ranges. Okay, with that said, guess what it's time for? It is time for your turn. Try these 2 out after you've paused, and then come back and see what. Okay, we paused. Now we're back. Write the function in function notation. Find the reasonable domain and range for each function. The temperature early in the morning is 17 degrees C. The temperature increases by 2 degrees Celsius for every hour the next 5 hours. Write a function for the temperature in degrees Celsius. In other words, what we have is we've got H is hours, and our temperature is based on the time. So the f of H, the value of the function with H hours, is, we've got this, it starts with 17 degrees, and each hour we add 2. You could have also written 2H plus 17, right? This was this part 1. Part 2 is to find the reasonable domain and range. So at time 0, so our domain, we have a time 0, which we know, we have a time 0. We could have 1, 2, 3, 4, and 5 hours, because it just says for the next 5 hours. Now we need to figure out those ranges. At time 0, at hours at age 0, H is 0, 17 plus 2 times 0, or 17. My first temperature is 17. Then it goes up by 2. 19, 21, 23, 25, 7 degrees Celsius. And this domain and range, reasonable domain and range. Number 6, Takumi earns $8.50 per hour proofreading advertisements at a local newspaper. He works no more than 5 hours per day. Write a function for his earnings. In other words, H is hours, seeing a theme here. H is hours, and the value of the function, if he works H hours, is $8.50 times the number of hours he works. 850 times H, or 850H. That's my part one. My part two, my domain, he could work 0 hours. He could work 1, 2, 3, 4, or 5 because he's working no more than 5 hours. So my range in this case, let's plug the H values in. My range in here, if he works 0 hours, you'll be a shock to hear this. He makes $0. And this is hours. If he works 1 hour, he makes $8.50. 2 hours would be 17. 3 would be $25.50. Let's see, 0, 1, 2, 3, 4 hours would be, let's see here, $34. And 5 hours would be $42.50. Again, this is dollars for the range. So using that, we found a reasonable domain and a reasonable range. Okay, that's all kind of coming together, right? You think about the domain, the range, the dependent, the independent, reasonable values. There we go. There we go. I think we're on to something. And what we're on to is practice. We are talking about practice. So with that said, I hope you guys have a great day. Check the practice part in Google Classroom to see which practice you need to do. Take care. Have a great day.